So I've been thinking about this problem here. So the concept of digital twin has been used in engineering quite a bit. So what I would like to do is to bring that into software. So I'm going to talk about how to use digital twin in C++ and Smalltalk. I guess the motivation is to understand complex software better and to combine the best of static and dynamic languages. C++ for speed, Smalltalk for flexibility. And then one of the benefits of a twin is that the redundancy can reduce bugs by orders of magnitude. So feel free to stop me.
Comme là, moi j'avais des pop-up pour 3 heures l'après-midi, j'avais 3 détaillants à désactiver.
Benoit?
C'est rare que je me fais des détaillants à désactiver à 3 heures l'après-midi.
Is that sound coming from you?
Là, il y en a un qui m'a payé à l'avance.
Is it,
il y en a une qui va vendre, je le sais, l'autre qui...
Yes, it was Benoit. So, sorry, I've moved to you now, but, you know, Aik-Siong, if you want to continue.
Okay. So the digital twin concept was introduced in 2002. Again, like I said, in engineering. So the idea is that you have a physical object, and then you want to create all the information about the physical object in a digital twin. So this part here, can you see my cursor?
Yep.
Yeah.
Yes.
Okay, good. So this is the digital twin. Hopefully we can do a lot of query and changes on the digital side before we do things on the physical side, which is difficult. Simulation comes into the picture also. But the idea is you have a physical object and then you have the software version or the digital version of that object. The concept itself is not all that new. Perhaps the name is new. I would think that simulation satisfies the idea behind a digital twin. Okay, you have this physical system, and then you have the simulated system right here. Okay. So, to date, almost all versions of digital twin is one physical object, and then you have the digital version. So what I'm trying to propose that I think is new is to use the idea of a twin for software. So we have this system here, the C++ production program. All right. And this is what I call difficult. All right. I spent 2 years programming in C++ recently, and the ability to change things, the ability to discover things is very, very limited. So the idea then is to have a digital twin in a nice language like Smalltalk, where the ability to explore, interrogate is 10 times, 100 times better than what C++ offers. So the idea then is to have a twin where the same input should produce the same output. And this program here doesn't have to be the whole entire program. It could be part of a program or any convenient component of a program. Right? So you don't have to start implementing this all in one go, but in bits and pieces. So why do you want this? Okay, C++ is fast, but it's complex. C++ is the best of the fast, okay? there's no running away from being fast. Whenever there are just two programs to compare, the customer will just say, which one is faster? Okay. Any additional features just doesn't matter to the customer, because they usually have a very limited scope and they just want to solve that scope as fast as possible. So wherever there's two programs, they will pick the one that is fastest. And of course, invariably C++ will win in that race, you know. But for the developer, trying to do things in C++ is just tough. We all know that, so I don't need to tell you that. So Smalltalk will fill in the gap. Smalltalk is the flexible one. Smalltalk is the best of flexible. So the digital twin will combine the best of the fast and the best of the flexible. Just to give an analogy, C++ is a Formula One vehicle. Smalltalk is an all-terrain vehicle, nimble, rugged. Okay, a hybrid vehicle would just be unsatisfactory. Okay? C++ requires heavy infrastructure, and the ability to explore is limited. Smalltalk, the infrastructure is light, and the ability to explore is huge. But we want both. Okay, we want both. If your execution speed is not the fastest, you're not going to win the contract or the client. If you don't have a flexible ability to innovate and modify and debug, then your development process will be slow. Let's see. So again, what's going on here? Why digital twins? Well, C++ is machine-centric for fast, for speed. Smalltalk is programmer-centric for development speed. So humans think in objects, which what Smalltalk satisfies beautifully. And we want to develop at the speed of thought. No need to wait for compilation, linking, and just heavy build processes that just takes a long time. So this is all quite familiar to us all. So the idea new is to combine both. So what do you get out of this? Well, the twin can help in documentation. The twin can be a substitute for documentation. Smalltalk is readable and less verbose than English. Now, this is the bonus that you get when you do have a digital twin. Not only do you have the ability to explore, you also have something as sort of a, I don't know what to call it, bonus, because the twins reduce bugs by checking each other. Okay, the probability of the two quite independent programs make the same bug is the product of probabilities of each having the bug. So this is the same technique that is used in aeronautics, where the safety of the aeroplane is enhanced greatly by using lots of redundancy. So the probability of everything failing is very, very small compared to the probability of one thing failing. So the strategy for the twins: capture the C++ algorithms in Smalltalk twin. This is sort of what I call executable documentation. Experiment in Smalltalk twin, and this could be a superset of features. Fearless programming. Then you transfer the discoveries to C++ twin. This can be done manually or automated, or both. Strict testing is done, and then you iterate between the twins to, you know, to get that quality that the twins should give to a program. So if the this iteration of these two twins will improve quality. And then debug and twin transfer fixes to C++. So debugging is also enhanced, not just in discovery. Debugging can be done easier in Smalltalk than in C++. So just to show that the digital twin idea is not too far-fetched, okay? I try to combine prototyping versus digital twin business production. In prototyping, you don't have a production software. You just want to get something out very fast. So you're prototyping in a simple, nimble and simple language. Once you find that it's proven, you then create the production version, which is fast and more complex. And then you hopefully proceed and your business grows. But when this is successful, usually this is either terminated or neglected, all right? So the concept of the digital twin is quite simple. You prototype and you never stop prototyping or continuing it so that you have a digital twin of the software in the prototyping flexible language, and you have the production in the fast language. So digital twin just lives here. And of course, what I'm trying to introduce, which is new, is that even if you have a successful production language software, it is still beneficial to recreate a twin in a flexible language so that you can use this to explore new areas, new features that this production software can't do, or it makes it very difficult. Okay? Production software can be really difficult to change. So if you are trying to explore using production software, it's just, yeah, a lost cause. Okay, I think the rest, I think we're all small talkers, so there's no need to emphasize why I chose Smalltalk as a flexible language. Okay, it's all Smalltalk stuff, which maybe non-small talkers I would make a presentation. So coming back to summarize, C++ production program complements and checks and balances with a Smalltalk program. Right. So conclusion, C++ was speed. It's highly desirable in terms of production software. It encourages what they call it, it helps you to win in the business. Smalltalk for flexibility so that it can develop at the speed of thought. And then the twin reduce bugs by checking each other. Okay. Smalltalk was invented right. Anyone can own Smalltalk. Well, so that's the new idea. I don't think I've seen it anywhere else. And I'll be glad to hear what you guys think. That's it.
Thanks for that. I have a question. So what is the overall speed or the loss in speed by basically having to alternate between two implementations.
Now, what do you mean by loss in speed? Do you mean the additional effort to maintain both twins?
Yeah, so there's, since you basically need to maintain both twins instead of just one implementation, there's gonna be a nominal loss in speed. I'm not saying that it's a bad thing, right? Even if it's there, it's just
Okay.
that
I think it's all to gain, because if you try to explore in C++, okay, just to, let's say I have method 1 that is running in production. I want to check if method 2 is better than method 1 in. Okay. Now I want to write the whole development program in C++ to execute method 2. That is going to take a lot more time than writing a Smalltalk program to execute method 2. Right?
Yeah.
So you then explore with method 2 using Smalltalk. Then you can decide whether it's good or bad, or maybe tricky.
Okay, I get your point.
Yeah. So if you're just to gain, I mean, the effort to do method 2 in Smalltalk is definitely less than the effort to produce method 2 in C++. Now, given the flexibility in Smalltalk, you can try method 3, method 4, and then decide 2, 3, or 4, which is best. And when you think that you found one that is really good, then you copy it into C++, you see? And in C++, then it should be quite straightforward, because there's no more experimentation. You just write it out in C++.
Mm-hmm. Okay. Yeah, I was looking at it from the point of view of, started from the Smalltalk side of things, right? So, if you
looking at this from the point of view of what?
Of starting from the Smalltalk side of things as opposed to from the C++ side of things. You say, well, compared to actually having to explore different solutions by inspecting and modifying the C++ artifacts, it can be faster to actually redo that specific work in Smalltalk and explore there. I was thinking, well, my default was, okay, well, what if I'm already in Smalltalk, right?
Yeah, I mean,
yeah.
I mean, what? It's sort of, there's some study that says Smalltalk is 5 times more productive than C++ or C in terms of coding ability. So that's the plus that you get. So you're not actually wasting time doing things in Smalltalk. You get the value back that you would have put in the C++ method 2.
Yeah. Yeah, I agree with all this. Yeah.
And then the added bonus is that now you have 2 programs that are sort of different, and then you have the same input and you should get the same output. But because the 2 programs are slightly different, they will check one another to make sure that your logic and execution and all is truly correct. Yeah.
Okay.
So yeah. So I think if Smalltalk is to have a rebirth, this would be a good idea to to do that, because I don't think I really think this might be the future of programming, where we have the best of both worlds, static and dynamic programming, solving a single application. And this could be applied throughout everywhere.
Okay.
No more compromises. In fact, lots of advantages.
Okay.
Dan, are you hearing me?
There is a question
Yes.
And
And
Yeah.
Ingalls, yeah. So yeah, you are the one that came up with all the ideas of Smalltalk to make it really flexible and productive. And proposing an idea to really use that.
so just since we're recording this, so Dan's question is, do you consider slang to be providing such a benefit?
Yes, I saw a brief slide that you zoomed by that had slang on it.
Right. I think slang would be, yeah, a test of the digital twin idea already.
And I guess its limitation is that it only works for non-message sending situations.
Yeah. I mean, ultimately, if you think about it, do we need to program in a difficult language like C++? Right now, for example, we avoid programming in assembler. So can we avoid programming in C? Can we avoid programming in C++? and do it in the most productive language, Smalltalk. So
Well,
at
as
present,
an anecdote, I can tell you that slang was born out of my desire to not have to program in C.
Correct. And indeed, so yeah, we're just pushing it one further level, because slang is still not object-oriented,
Right.
Yeah, basically slang is making Smalltalk look like C. So I'm just thinking that we should go from full Smalltalk object orientation to executable code that is fast, which may be C, which may be C++ or something, Right.
Well, I just wondered if you're aware of anybody who might be working on alternatives or extensions to slang that gave you that property. Because certainly to the extent that it's possible to actually run, where it's a push button change from one to the other, rather than the need to to sort of change one program and change the other. That saves a lot of time.
So roughly, I mean, haven't tried. C++ has at least objects. So we could at least transfer Smalltalk objects to C++ objects. And then, I don't know, I mean, yeah, so that would seem more closely in a translation that is more meaningful to Smalltalk. Yeah. Anyone, Craig, have you tried something like Smalltalk objects to C++ objects? What problems would arise doing that?
Not really a C++ developer, but sorry, go ahead, Craig.
Oh, okay. Yeah, sorry, it took a while for me to get to the mic. No, I haven't felt the need to make my fast target also be message oriented or structured as objects. I just want it to be fast. So I haven't played around with C++ in particular yet. I've only been playing around with, I guess, lower level things. I guess C is as high level as my backend targets have gotten. I'm mostly working in assembly language.
Right. But you're not programming Smalltalk to produce that C and assembler, right?
Yeah, I am. Beginning with slang from Squeak, and then moving on to, well, these days WebAssembly. Yeah, so I guess with Slang, we were generating C source code and compiling that. But with WebAssembly, I'm transpiling Smalltalk compiled methods directly to WebAssembly. So I'm translating from the Smalltalk instruction set, the bytecode set, to the WebAssembly instruction set.
Okay.
And so far, the need to structure things, using messages or objects per se at the assembly level hasn't come up just because I'm limiting the places where I'm using the assembly language to, really simple repetitive operations that don't really need those things. But I could imagine getting to a point where I do need that. And I think it will be possible to build sort of a minimal infrastructure for doing that kind of thing on the assembly language side, but I just haven't gotten there yet.
Okay, good. So do you see the digital twin concept in any of what you are planning to do? Do you see anything that I've said today that that is helpful to what you're going to do?
Well, I like the idea of sort of having regression testing, these two implementations checking each other. I like that idea. So from a testing point of view, I like it. Yeah, I have to think about the other points.
Good, thank you.
Yeah.
So I've been working for the last couple of years, taking several different runs at this problem. My approach is similar in some ways, but different in a different way. So my view is that everybody who has a choice would prefer to program in Smalltalk, but then I want to take from that Smalltalk code and produce something that runs in other environments. So I gave a talk at the 2019 ESUG about one ring to bind them all or something like that, where I was talking about a Java translation that I was working on, because Java is closer to Smalltalk than C++ is, and I also had a talk in 2018 about all the pieces that you need to emulate Smalltalk primitives in Java. So how do you handle exceptions, and how do you handle blocks, and how do you handle non-local return, and those kinds of things. So the challenge for all of that is you need a type inferencer. So I have a PhD student who's working on type inference, like full program, not full image, but full program type inference for Smalltalk. And so when that is ready, then I will be generating code for a variety of different environments, including the Java VM. So I think it's an interesting idea that you put forward, although I unfortunately arrived late, and so I just caught the last slide. But I get the principle of what you're talking about. It's a good idea. I think it actually would allow a lot of people that maybe discard the idea of Smalltalk to maybe think about, yeah, if I could actually develop my code twice as fast and then parallel it, that was an interesting approach from a software engineering standpoint. But my approach is okay, and I don't want to have to then turn around and write the C++ or Java code at the other side. But
yeah, thank you. Yeah. Okay, maybe this slide here. Okay, this is the one. So the digital twin that I'm proposing will show up at this point and at this point. So that's the gap that I feel that digital twin can fill in our modern practices that can help programming in the future.
Yeah, I think it's a really interesting software engineering approach, or approach to engineering software. First thing, I would just want to press it, like Dan said, I just want to press a button and produce the executable in whatever horrible language is necessary. I don't want to then have to turn around and write horrible code.
That's if I want to publish this in a paper of some sort as a what would you suggest, Dave?
I would suggest a software engineering approach rather than a programming languages, because I think that
Okay.
what you're describing is a really interesting approach to software engineering, i.e., develop in a language that is flexible and powerful and has a great development environment, and then maintain a parallel version after, build a parallel version in a language that fits in your deployment platform, and then maintain that parallel. So we also did Pharo.js, which is develop in Pharo and deploy on the web. So we transpiled to JavaScript. But again, that's a press a button and it's done thing. You do all the work in Smalltalk and then you don't have to do the JavaScript.
Right. What journal specifically would be a good candidate?
I would suggest one of the Smalltalk conferences as a first run, either ESUG, like the International Workshop on Software Smalltalk Technology, or VAST would be first shots, I would say.
Okay. Thanks.